Welcome to the DIY Honda Garage channel. The DTC P0340 indicates a problem with the CMP, Camshaft Position Sensor A, which is not receiving a signal, and this can affect engine timing and performance. The problem may cause the engine to misfire, stall, or not start at all. The CMP Sensor A typically is located near the camshaft and is crucial for accurately determining the position of the camshaft relative to the crankshaft, allowing for precise timing of the engine's ignition and fuel injection systems. The data collected by this sensor is sent to the PCM, Powertrain Control Module, which adjusts engine operations based on the readings. A malfunction can stem from poor electrical connections, wiring issues, or sensor failure. Addressing DTC P0340 promptly is vital for optimal vehicle performance and engine longevity. The CMP Sensor A plays a significant role in ensuring that the engine runs efficiently by tracking the position of the camshaft. It sends critical data to the PCM about the timing of the camshaft, which is necessary for the engine's ignition and fuel systems. Typically, this sensor is strategically placed near the camshaft, allowing it to read its position accurately. When the signal from CMP Sensor A is interrupted or damaged, it leads to DTC P0340 being triggered. Consequently, this can cause a range of engine performance issues, such as irregular idling, poor acceleration, or stalling. If this DTC is recorded, proper troubleshooting is necessary to either repair or replace the sensor or address underlying electrical issues. The possible causes of DTC P0340 include a faulty CMP Sensor A, which may fail to produce the required signal due to internal defects. Another significant reason could be an open circuit in the wiring between the CMP sensor and the PCM. Damaged wires or loose connectors can create interruptions in the electrical flow, often resulting in a no-signal condition that prompts this DTC. Poor connections at the CMP Sensor A and the PCM are also critical issues to check, as they can prevent signals from being transmitted effectively. Each of these possibilities necessitates thorough investigation and diagnostic testing to ensure that the correct repairs can be made. Addressing these causes promptly ensures the vehicle's engine operates smoothly. When DTC P0340 is triggered, several symptoms may manifest, significantly affecting vehicle performance. One prominent symptom is the engine's inability to start, as the ECM, Engine Control Module, relies on the signal from the CMP sensor to initiate the ignition process. Stalling issues can also arise, particularly when the vehicle is idling or under load, due to inconsistencies in engine timing. Drivers may notice poor acceleration since timely fuel delivery and ignition timing are compromised. Additional concerns might include erratic engine behavior, such as misfires or reduced power. Recognizing these symptoms early can assist in diagnosing the issue before it exacerbates, potentially leading to further engine damage. In the first troubleshooting step for DTC P0340, you must turn the vehicle to the on mode, which powers the vehicle's electrical systems without starting the engine. Following this, utilize the HDS, Honda Diagnostic System, to clear any existing DTCs. Clearing the DTCs allows you to restart the diagnostic process. After clearing, start the engine to see if the DTC is still present. It's important to check for both pending and confirmed DTCs using the HDS. If DTC P0340 reappears, it leads you to the next step in the troubleshooting process. If it does not, you may be dealing with an intermittent failure, suggesting a need to inspect for poor connections or loose terminals at both the CMP Sensor A and the PCM. For the second troubleshooting step, Turn the vehicle to the off lock mode to ensure all systems are powered down. Next, disconnect the CMP Sensor A's 3P connector to isolate the sensor from the circuitry for testing. With the sensor disconnected, switch the vehicle back to the on mode. This is done to measure voltage at 2 test points. You will need to measure the voltage between the 2 test points specified, where test point 1 is on the CMP Sensor A connector, female terminals, number 1, and test point 2 is body ground. If you find approximately 5.0 volts, this indicates the VCC2 volts at the CMP sensor power supply line is functioning correctly, leading you to further troubleshooting steps. If not, you will continue to the next step to check for additional issues. In this step, again, turn the vehicle to the off lock mode, ensuring safety while you work on the connections. It's important to jump the SCS short circuit line with the HDS and wait for more than 1 minute. This procedure prepares the system for continuity testing. Next, disconnect the PCM connector E, ADP, so that you will have an open point for your continuity test. You will then check the continuity between 2 test points. Test point 1 is the CMP Sensor A 3P connector, female terminals, number 1, and test point 2 is the PCM connector E, ADP, number 77. If there's continuity, the VCC2 wire is deemed okay. If continuity is absent, it indicates there is an open circuit in the VCC2 wiring that requires repair between the PCM and the CMP Sensor A. For this step, you need to verify voltage again, specifically for the TDCAM, TDC angle measurement line. Start by measuring the voltage between test points 1 and 2. Test point 1 should again be on the CMP Sensor A 3P connector, female terminals, number 3. Test point 2 will be body ground. This test is crucial to determine if the TDCAM line is operational or faulty. If you measure about 5.0 volts, the TDCAM line is functional, leading you to the next troubleshooting step. If there isn't approximately 5.0 volts, further diagnostics must be conducted to identify issues in the connected wiring or potential faults in the sensor. Moving forward, this step concentrates on the SG2 line, which is critical for the functions of the CMP sensor. Once again, measure the voltage between the specified test points, wherein test point 1 is the CMP Sensor A 3P connector, female terminals, number 1, and test point 2 is female terminal number 2 of the same connector. It's vital to ensure that you are in the vehicle on mode with the connector disconnected for accuracy in your measurement. Should there be approximately 5.0 volts present, it confirms that the SG2 wire is intact, indicating that further investigation might be needed for the CMP sensor itself. If the reading is not as expected, this directs you to check the next steps for wiring issues that may affect the SG2 line. In this 6th step, you will again turn the vehicle to the off lock mode. This is essential for safety during testing. Following this, activate the SCS short circuit line using the HDS for a minute as a precautionary measure. After the waiting period, disconnect the PCM connector E, ADP as you prepare for a continuity check. Measure continuity between the CMP Sensor A3P connector, female terminals, number 2, and the PCM connector E, ADP, number 78. If continuity is confirmed, the SG2 wiring is functioning correctly, and further investigation into authorized service bulletins or potentially replacing the PCM may be warranted. Should continuity not exist, an open circuit in the SG2 wire between the PCM and the CMP Sensor A requires immediate repair. During this step, the vehicle must be switched to the off-lock mode, aligning with safety protocols while working with electric systems. Afterward, Engage the SCS, short circuit line, with the HDS for more than a minute to prepare for testing. Disconnect the PCM connector E, ADP, so that you can check specifically for shorts in the TDCAM line. This involves measuring continuity between the PCM connector E, ADP, number 43, and a body ground point. If continuity is found, it indicates a short that needs addressing in the TDCAM wiring. However, if continuity is absent, proceed to the 8th step, where you will further examine for open circuits that might be causing the failures. In the final step of this troubleshooting process for DTC P0340, you will check the continuity of the TDCAM line extensively. Ensure the vehicle is in the off-lock mode before proceeding to test. Measure the continuity between the CMP sensor A, 3P connector, female terminals, number 3, and the PCM connector E, ADP, number 43. This test is crucial to confirm whether the TDCAM wiring is intact. If continuity exists, this indicates that the TDCAM line is functioning correctly and directs you to further explore the PCM for possible issues. Otherwise, any lack of continuity affirms that there is an open circuit that requires immediate repair between the PCM and CMP sensor A. Once all relevant repairs are completed concerning DTC P0340, it is vital to conduct a final verification process. Begin with a comprehensive test drive to observe the vehicle's performance in real-world conditions. Monitor engine operations, including acceleration, idling, and overall responsiveness to throttle input. After the test drive, check the vehicle for any DTCs using the HDS to ensure that DTC P0340 is no longer present. This step is critical, as it confirms that the repairs have resolved the underlying issues of the code. If the DTC persists, deeper diagnostics may be required to further investigate other potential causes that weren't addressed. A successful verification indicates the problem has been resolved satisfactorily. To prevent future occurrences of DTC P0340, it's essential to engage in regular maintenance protocols. Scheduling routine inspections of the vehicle's electrical systems, specifically focused on connectors associated with the CMP sensor and PCM, can prevent issues before they arise. Consider performing visual checks for any signs of wear, corrosion, or loose connections that might disrupt electrical signals. Furthermore, ensuring that sensor health is maintained through periodic replacement or servicing can also contribute significantly to the overall reliability of your engine's performance. By proactively addressing these areas, you can help extend the lifespan of the CMP sensor and maintain your Honda Accord in peak operational condition. This also promotes a more efficient engine and reduces the likelihood of further diagnostic trouble codes. In conclusion, DTC P0340 emphasizes the importance of the CMP sensor in maintaining optimal engine performance. Understanding its role in engine timing and fuel efficiency is critical for all vehicle owners. Prioritizing the integrity of wiring and connections is necessary to prevent disruptions in the electrical signals essential for sensor functionality. Execute thorough diagnostics to accurately identify and rectify issues that trigger this code. Consistent preventive maintenance and detailed troubleshooting procedures can significantly minimize recurring problems, ensuring your Honda Accord runs smoothly. Engaging in these practices not only improves reliability, but also enhances overall driving experience. Please like and subscribe to the channel. See you next time.